Light travels at about 300,000 kilometers a second through spacetime. As it travels through space, space expands as well. During its travel, it experiences zero time because of how fast it's going. Um, Zero time equals zero space because it's space-time. This is what that looks like. Zero space, zero width. Where am I at? So if we have zero width, electrons communicate and agree to exchange a photon, and these arrows suggest or indicate that space is expanding in 2 dimensions, not 3. And then I have this dimension because this is what we dwell within. And as the space expands, redshift occurs between these 2-dimensional electrons. Um, this is the the journey of a photon, though. This is what the photon experiences, even though we get to experience the wave exchanged between electrons or otherwise. This is what a photon experiences. Start, and that's it. 2 dimensions, the width is gone. And this is zero space-time. That is the life cycle of of a photon as it experiences itself. And so I asked, where does the energy from a redshift go? Because I know I didn't illustrate it here, but most light emitted in space, especially, is of really high intensity, high velocity, high frequency, high everything, high power, whatever, pretty much whatever. It's very powerful light that gets redshifted over time. So what happens to the energy from the powerful light that got redshifted? In my opinion, it is as if, and because this is 2D, I asked myself as well, how do you redshift something that's 2-dimensional? How do you, as light experiences itself, as light experiences its start and end journey of zero space-time, how does redshift even occur? And it came to the conclusion that it experiences something similar to centrifugal force, where space pulls it apart. It, you could think of it similar to that. Even though the wave propagation is technically like back and forth like this, when space-time expands, you start out like this, and then as space-time is expanding, you get bigger and bigger and bigger, and it gets slower, and it redshifts. So it's similar to centrifugal force in the way that space expands I don't know, the way that light moves through space-time. And this is, I know it's not like perfect, but this is essentially how it works, how it looks like. As space-time expands, the wave is expanding. And then I drew it from this. angle. So this is like a side angle, side profile of a light traveling through space. And this is a profile of light traveling at you, or in your direction anyways. So this small square is where it starts, and then this large square is the expanded space through time. And light is traveling through space at you. And I realized this could be interpreted as two-dimensional, so I drew that here. And this is sort of what light would experience, I think, as itself. And so where does energy go when redshift occurs? Because we start out with intense light, and over time space sort of sucks the energy out of light and redshifts it. And I came to the conclusion that it it helps space expand. So the energy lost from the redshift actually goes to the expansion of space-time. It basically pushes space. All of that light, that energy from the light lost, kind of pushes space to expand further. And at the same time, it's almost as if space-time is sucking the energy out of light to continue, or because of its expansion. So it's a sort of, and it's because of the way that you view the interpretation of light. Are you viewing light as the particle that is traveling with zero space time, or are you viewing the particle as something that we see through space time, a wave? So I guess it depends on which one is which. And I think if you're viewing it as a wave, then because it's in 3 dimensions, we see waves through 3 dimensions. Um, then it seems as though space-time is expanding that wave. But if we view a perspective from the photon, it's almost as if the energy lost from the redshift is causing space-time to expand. So that's my big picture of light in a nutshell. Anyway, bye for now.